Hi, I'm Professor Angela Rasmussen from the Electrical and Computer Engineering Department at the University of Utah. Today I wanted to do another example for a diode analysis. So this is our circuit this time. So we want to find all of the quantities, and then we want to find the instantaneous result, which will be the combination of DC and AC. So recall that we're going to analyze these like superposition, where we're going to look at the DC solution first and then look at the AC solution. So the DC solution, you're going to remove the AC sources. So in this case, we're going to ignore that AC part, and we're going to analyze it with just the DC. So this may be a new notation for you. All that means is wherever this is connected, that will be the positive. So here, that would be the positive side of your supply, and then it's in relation to ground. So the plus side is always going to be connected at the same node as it is in the circuit, and then it goes to ground as an assumption. So that's what you don't see in this circuit. For the negative one, again, wherever it's connected, it will be the positive to ground, and the value of it will be the value of the source. So in this case, it will be plus to ground with a negative 10 value in there. So we're going to figure out what we're going to assume first. And so for diode 1, we're going to actually assume that it is on. And so we're going to replace it with this battery. And it's going to have the same polarity orientation as it does in the circuit. And then this has a negative to plus 4 volts. And for diode 2, we're also going to assume it's on. So both these were assumed to be on. And we're going to also orient it in the same direction as its polarity. So the negative side always is on the side of the diode that has a little line. So I2 goes from the plus side to the minus, and then I1 also flows in the same direction as the diode polarity. So from here we can analyze it. I would suggest node voltage. So we would have the current in this branch is going to be V0 minus 10 over 2K. The current in this branch is going to be V0 minus 0.7 minus a minus 4 over 20K. And then the current in this branch is going to be V0 minus 0.7 minus a minus 10 over 20K. And we can combine these with all of the same terms. So 1 over 2K, 1 over 20K plus 1 over 20K. And then the other terms go to the other side. So the minus and minus becomes a plus. And then you take it over to the other side, that becomes a minus. And this minus minus becomes a plus, and again it becomes a minus on the other side. So this whole quantity, I'm going to combine this, so I'll have a 10 on the top, and that will become a 20K on the bottom. So I would have 20K divided by 12, and so this gives me a V0 that is going to be equal to a 7.3 volts. So now I can find I1. So I1 is located here, so that's going to be V0 minus 0.7 minus a minus 4 over 20. So it's this term in that node voltage equation. So ID1 equals 7.3 minus 0.7 plus 4 over 20K. And that gives a value of 0.53 milliamps. And this branch had ID2. And that was 0.83 milliamps. And then we need to check that our assumptions, in this case we assumed both of them were on. So both of them are greater than 0, so therefore both are on. So that concludes the solution for the DC side. Now we need to move to the AC solution. So for the AC solution, I'm going to copy the circuit, and we're going to now leave in the AC source, and we're going to remove the DC. So removing the DC means that it will go to 0. So therefore that will go to 0. And the negative 10 over here will also go to 0. So this becomes ground. Our 4 volts also gets shorted because it becomes 0. So that becomes a short. And then we're going to assume both of these are on, so we're going to replace them with the resistors, an RD1 for the diode 1 and an RD2 for the diode 2. And their values are determined by that NVT over ID. So for the second one, it will become ID2. And so our N was given to us as 2. VT was also given in this case as 25 milli. And so our ID2 is this 0.83 milli. And so we plug those values in. Remember, milli is 10 to the minus 3. And that gives us 60 ohms for RD2. And RD1 is going to be 2 times the 25 milli. And then ID1, which is the 0.53 milli. And that gives a value of about 94 ohms. So now we want to analyze the circuit. Again, we can use node voltage. And so we can use V0 minus a 0.01 sine omega t over 2K plus V0 over 20K plus RD1 plus V0 over 20K plus RD2 equals 0. And then we can combine all of the the V0 terms. RD1 was 94 and RD2 was 60. And then we can divide this there, and then we can get a value for V0. And in this case, it becomes approximately 8.3 milli sine omega t. And so our total value for V0 is going to be the DC value of 7.3 volts. And then this AC value. And that is all in volts. And that is our conclusion.